Welcome to Technically Speaking, where we help you increase your income through tech. All right, so welcome to week one of your tech journey. And today we're going to be talking about introduction to technology and computers. So by the end of this lesson, you will understand what technology is and how it shapes society, how computers work and their key components, a brief history of computing and its evolution, and then we'll do some hands-on activity on how to assemble a basic computer from components. All right, let's dive in. What is technology? Now, by definition, technology refers to tools, machines, and systems created to solve problems and improve human life. It includes everything from the wheel to artificial intelligence. Now, technology impacts society by communications, or I would say with communications, such as phones, internet, social media. It allows that instant global connection. Healthcare, medical technology has extended life expectancy with MRI scans and even robotic surgery. Online learning platforms like Udemy, Coursera, and ChatGPT enable self-paced learning to enhance education. And e-commerce, automation, and cloud computing have transformed industries with business and the full economy. Now, quick question. Can you imagine a day without technology? What impact would it have on your life? Computers process data, execute instructions, and store information using hardware and software. Let's break down the key computer components. So we have CPU, which is central processing unit. This is the brain of the computer. It processes instructions. Then we have RAM, random access memory. This is short-term memory that stores running applications. We have storage, HDD and SSD, which is long-term memory that keeps files, software, and the OS. GPU, graphics processing unit, which processes graphics and speeds up visual tasks. Don't forget the power supply, the PSU. This converts electricity into usable power for the computer. Keyboard, mouse, monitor, printer, speakers, and all that other stuff, those are our input and output devices. Look at your phone or your computer. Can you identify these components? Now, computers have came a long way since their creation. Let's just go over a brief time. So we have the 1940s, where the first computers were room-sized and they used vacuum tubes. From the 1950s to the 60s, a transitor revolutionized computing, making these machines smaller and faster. So then the 70s and the 80s came along and personal computers, PCs, emerged. And this is where Apple and IBM came into the talks. The 1990s and early 2000s, the internet became mainstream. Laptops and mobile devices grew bigger. And we have 2010s until now, where AI, cloud computing, quantum computing, and even blockchain innovations are taking over. Quick question. What tech invention had the biggest impact on your life? All right, so let's do some hands-on activity with assembling a computer from components. Now, in this activity, you will explore PC assembly using a site called PC Part Picker. And you'll do some online research as well. And what you're going to do is design a functional PC build for a specific purpose. And then you're going to create some type of report or video presentation to explain your choices. So let's just go over a flow. So the first thing you would want to do is define your PC build purpose. So you're going to choose, what do you want to build this PC? What do you want it to do? You can have a PC, a gaming PC, maybe something for content creation, video editing, graphic design type PC. or maybe just one that's just efficient for work and browsing, like a home office setup. You can even do something with blockchain, maybe a blockchain node or just something that's optimized. And AI and ML. You can maybe build a computer that has high computing power for AI tasks or machine learning tasks. So definitely pick your purpose of one of these here. Step two, you're going to research and select your components. So research how to build this computer that you want, whether it's a blockchain or an AI computer or basic computer. What components do you need? How do you build this? I love AI. I love ChatGPT. So I would say go to ChatGPT, even on the free version, and ask about how to build your specific computer. So as it tells you how to build, it's going to tell you some of these components. Just make sure that when you go to PC Part Picker and you're using ChatGPT to include these items in your build, which you would by default, because you need a CPU, a GPU graphics card, a RAM, your memory, your storage, SSDs, your motherboard, your power supply, and your case and cooling system. Make sure you mention all these things here in your PC build. Okay. Also, as you go to PC part picker, you'll see that they have different parts based on your needs, based on performance and price. And I want you to go through all of that and take a look. After you have researched what parts you have, you pick the parts on PC Picker, you would explain your choices. And you would explain it based on, did you pick this type of CPU based on performance or based on budget? You know, why did you choose these specific parts? How do the parts work together? How do the CPU works with the motherboard? And with your build that you created, can your build be upgraded? So is it future proof? And just how well does your PC just serves its purpose? Again, is it for gaming? Was it for graphic design and so forth? Now, once you justified your build, the next step would be to create your presentation. You know, so you would write that justification in a report, PDF, or maybe you're a visual person, so maybe you want to use Canva or PowerPoint. Or you can even take it a step further and do like a video presentation, something with like Loom or YouTube or even TikTok, right? Some type of recorded walk. Now you're going to submit this project, whether it's in a video or an infographic or even a PDF. You'll submit it in Discord and we'll give you your feedback as a collective. Okay, so welcome to this session on building a blockchain optimized PC. So today we're going to cover the key components required to build a high performance machine for blockchain applications. So whether you're going to run a full node or you're developing smart contracts or just mining, this build right here is going to be designed to handle intensive blockchain operations. Let's move on. If I can get my mouse. A blockchain optimized PC is necessary for efficiently handling blockchain workloads. And this will include running blockchain nodes like storing and validating those transactions on a decentralized network, running test environments for Ethereum, Algorand, and other blockchains. So we got smart contract development, mining and staking, which is proof of work mining, which requires that GPU, CPU power, while the proof of stake benefits from just stable processing power. And then some use cases require some significant computing resources when it comes to AI powered blockchain applications. Now, the key here is speed, efficiency, and reliability. So this build is designed to provide all of those three things. Mhm. Now let's go over the essential hardware components that make up a blockchain optimized PC. So first off, we have the CPU, which I chose to be an AMD Ryzen with a 9 7000 series. This is really just their latest CPU. So it's going to come with that high core count. So you can multitask, run nodes, have all type of cryptographic workloads, and do everything you need to do on the back end. Next, we got the GPU. So I chose the NVIDIA RTX 4070 Ti. This right here says it's useful for GPU mining and machine learning applications. So just doing that on the back end of blockchain, that will be very helpful to make sure your computer's not crashing and is, running fast here. We have the RAM, which is 32 gigabits DDR5. And this just ensures smooth operation when running multiple nodes or doing virtual environments. I have this for storage, 2 terabits of non-volatile memory, SSD. I chose the Samsung 99 Pro. This is really just for fast read-write speeds, and that's just crucial for syncing blockchain ledgers. The motherboard to connect all this is the Asus Pro X570. This is, again, just for stable and reliability. It's going to support that high performance components that we selected, like the RAM, GPU, storage, etc. The power supply, 850 watts. It's a gold PSU. It's just making sure that we have a stable power delivery and power efficiency. To cool this system down, Noctua NHD15 air cooler. It keeps the system cool for 24/7 operations. That's the one I chose. And for the case, I chose the Factual Design Meshify C. It just allows good airflow and it's extra space if I wanted to upgrade. And for networking, at least 1 gigabit Ethernet card and a Wi-Fi 6E card as well. And obviously, we want to make sure we have fast internet so we can synchronize the blockchain. So all these components here balance that performance, efficiency, and longevity for my blockchain workloads. Now, to find these parts together, like I said, I did online research for chat on ChatGPT, just asking me, hey, what components do I need? Googled some components that I didn't really understand, and I picked all these on the PC Part Picker .com website here. I also was able just to check for compatibility to make sure that these parts are compatible of what ChatGPT gave me. Some of them weren't, some of them were too big, some of them didn't fit. So I did have to change some things like the air cooler, but everything was compatible and the performance was good as far as all together. And the deals I did, this is just a virtual, so I didn't pay for anything. However, if I was, I just ensured that I picked the correct pricing that I was comfortable with paying and exploring just different products. If they didn't have it, I was looking at Amazon, Best Buy, and so forth. So I would say always make sure you come here to the PC part picker so you can ensure that before you buy the actual parts to build your PC, it actually fits, it's actually compatible, and you're not just wasting money or wasting time sending back refunds or something in that such. Now, let's say you were to get everything all together, you was to buy all of these parts and put them together. Some step-by-step assembly, just really quick, is you would start off with installing the CPU, the central processing unit, onto the motherboard. You will align it properly and secure it in place, or have like a little CPU glue that you'll just pop down and like a little lever that keeps it into place. And then you will attach the CPU cooler, which is cooling that CPU so it can just continue to run. It's like a little fan on top of that CPU. After that, you would insert your RAM modules into the slots. So you have these RAM chips, they look like little chips here. and you just, pop them right into the slot. They're like Legos, so if it doesn't fit, it's not meant to be there. So they'll just pop right into place. And then you will take that motherboard and that has your RAM and your CPU. You will take that and put it into the case, and you will screw it down, make sure it's secured with screws. And then you would connect your power supply and install your storage. So, your power supply to make sure that your motherboard, everything gets power, and then your storage if you have like some SSD, non-volatile storage, something in that place. That should all be in its designated place. And then if you have your graphics card, go ahead and install that to make sure it's seated properly. Again, it's like Legos, it'll just pop into place if uh, it's supposed to be there. If not, do not force it. And then once that's all together, you're just going to connect all your cables. So you got your Ethernet cable, you got any other cables to your monitor, to your mouse, to your keyboard, all that jazz. And then once all your cables are connected, you would plug the power cable in and make sure that it's powered on. Now, since it's powered on, you're going to have to install an operating system. So since this is for blockchain, I would install either Windows or Linux. And depending on what I'm doing with it as well. Am I just mining with it or am I using it for multi-purposes? Uh, so Linux to give you more granular, Windows is more user-friendly. Just final thoughts on this to bring it back. This PC build that we talked about is optimized for running blockchain nodes without lag, efficient transaction validation and ledger storage, smart contract development and testing, and 24/7 uptime. So we can stake and mine different operations. This setup also allows for any hardware upgrades, so more RAM, storage, or even a better graphics card. And it's suitable for expanding into the AI realm. So if I want to do AI-based blockchain applications, I could do that and upgrade. Uh, Last but not least, as far as the cost, custom build PC that I see that I was able to build here, much cheaper and seems more powerful than going to the store and just buying a computer off the shelf, especially for blockchain use. So I would definitely recommend to build your own computer than to buy it off the shelf if you want to do something real intense with blockchain. So we went through the lesson, we did our homework, our hands-on activity. And if that was fun to you as far as picking PC parts and understanding RAM and SSDs and looking at AMD and NVIDIA products, then you might would like a job in hardware, some type of hardware related IT job. And here are the top in-demand hardware-related IT jobs for 2025 and beyond that you can look into and start studying. So coming in at number one, we have hardware engineer. So more of a computer and AI hardware development. This salary is going to start you off at 90K to 160K a year. It's in high demand because of the AI, quantum computing, and edge computing that's all expanding. So companies like Apple, NVIDIA, Intel, AMD, even Qualcomm are pushing towards hardware innovation for the AI, gaming, and cloud computing space. So we have the AI-driven chips. So we have NPUs that are becoming the standard in data centers, smartphones, and self-driving cars. And that quantum computing hardware development is also rising. So it's requiring specialized engineers, like hardware engineers. And if you want to get started, if you don't need a degree, but if you do, you can have one in computer engineering or electrical engineering will really help you. Or you could just self-learn like you're doing now. And you would just learn specific things like embedded systems or PBC design. And it would be great to get certified in like a vendor certification, like NVIDIA's AI hardware. So number two, cloud and data center hardware technicians. That salary is starting off at 70K, going up to 120K. It's in high demand because of the cloud infrastructure that's expanding. So that cloud computing is replacing traditional on-prem servers. but physical data centers are still needed. So you'll still be there to be able to have that hardware. AWS, Google Cloud, and even Azure are hiring data center engineers and technicians to build, maintain, and optimize their cloud infrastructure. And hyperscale data centers like AI processing, storage, 5G expansion, they require hardware experts. So to get started in cloud and data center hardware technician space, you would learn server hardware, learn virtualization like VMware, Hyper-V, and networking like Cisco and Juniper. You would definitely want to get certified, maybe an AWS certification in like the data center technician or an Azure cloud infrastructure certification. And you can just gain experience in those data centers to grow your salary. Number three, embedded systems engineer. This is more of the Internet of Things, IoT, robotics, smart devices. They start off at 90K, go up to 150K, and they're in demand because IoT is projected to grow to 30 billion connected devices by 2030. So that's smart homes, industrial automation, healthcare tech, and these AI-powered embedded systems will run things like self-driving cars, robotic assistants, and even smart medical devices. And automotive technology, wearable devices, and drone technology also requires hardware engineers who can integrate software and AI into physical devices. So how to get started with that? You would definitely learn C, C++ for embedded programming, learn PCB design, microcontroller programming, things in that such. Maybe even get you a Raspberry Pi and start playing around with that. Also, get certified in things like embedded Linux engineer or an ARM Cortex specialist, something in that sort. Building projects will be your game changer here as transitioning. So you want to build personal projects, build a smart home device, automated sensors, or even IoT security cameras. Number four, we have cybersecurity hardware engineers. This salary starts off at 100K. It's in high demand because hackers are always targeting hardware for vulnerabilities. You got firmware attack, BIOS, malware, and even chip exploits. The government and just certain corporations need hardware security experts to protect those IoT devices, the AI processors, and ICS, which is the industrial control systems. Now, companies like Intel, AMD, Apple, and defense contractors like Lockheed Martin or Raytheon, they need engineers for hardware penetration testing, firmware security, and cryptographic hardware design. So if that seems cool to you, you can get started by learning firmware security and IoT security. You can definitely get certified and be certified ethical hacker or the offensive security hardware exploitation certification, something like that. I would say you can start off by practicing with hardware hacking labs like Hack the Box and Try Hack. Last is five, network and telecommunications hardware engineer. So this salary starts off at 85K and it's in demand because 5G infrastructure is expanding globally. So it's requiring hardware engineers for cell towers, IoT networks, and satellite communications like Starlink. Edge computing is growing, so companies need local processing units, LPUs, to handle the AI and real-time analytics. And also networking devices, routers, switches, firewalls, IoT gateways. These require hardware specialists to ensure secure, high-speed data transmission. Now, how you would get started in this path is learn networking hardware. Learn Cisco, Juniper, Palo Alto, and you would get certified in Cisco like the CCNA, CCNP. Maybe you'll have a AWS or Azure networking cert. And you can work in the data center networking or telecom hardware design. So if you want to really just future-proof your hardware job, you want to focus on AI and high-performance computing, hardware engineering, cloud and data center hardware, so the AWS, Azure, Google Cloud, embedded systems and IoT security, hardware security and penetration testing, and last, 5G and edge computing network. Now, if those jobs seem interesting to you and you want to embark on that journey, here's a roadmap to help you break into the hardware tech. So this roadmap will give you the step-by-step to break into hardware technology careers. So it'll cover everything you need to know on a high level so you will have a structured approach. Step one, you want to identify your hardware career path. So you're going to choose a specialization based on your interests and future job demand. So you can do computer hardware engineer, where you're doing PCs, laptops, AI hardware, embedded systems engineer, where the IoT, robotics, and smart devices come in, cybersecurity hardware engineer, where you want a hardware security or hacking, data center, data center and cloud hardware technician. So you're learning AWS, Azure, and Google Cloud, or even network and telecommunications hardware. So you're going to learn edge computing, networking, 5G, all that jazz. So pick out of that which one interests you the most, because all of these are definitely in future job demand. Step two. So before you jump into advanced topics, you must understand how hardware works. So you're going to study computer components and how those components work together, just like the exercise we did previously. You can continue working on PCpartpicker.com, but definitely start building a virtual PC, start understanding how these components work in depth, all right? Some hands-on practice when learning some fundamentals is to really go and get like an old PC, old laptop, and inspect its components. Open it up and see if you can either make it work again or do some troubleshooting, or even just identify these parts. Step three, learn specialized hardware skills. So depending on your career choice, the path you chose, you'll focus on a specialized skill. So you would, for instance, let's say you're in cybersecurity hardware engineer path, you would learn firmware security, reverse engineering, and penetration testing. And you would study how hardware encryption works. So secure boot, HSM, TPM, and you would go and start studying and doing exam prep for your cert. Maybe you want to do the offensive security hardware exploitation cert, or even the certified ethical hacker exam is what you want to go through. So you would learn these specialized hardware skills. Step four, get hands-on experience. So to break into hardware tech, you need to demonstrate hands-on skills. So you want to do projects that you can build and showcase what you know. For example, build your custom PC and document that process. You can set up a small business network and document that process as well. Work on an IoT project, or you can perform a hardware penetration test. And the best thing to do is to contribute to an open source hardware project, like on GitHub. Step five, you get certified and apply for jobs. So this is the time where you did your exam prep already. It's time for you to take your exam and get certified. Once the certification is good, go ahead and start applying for jobs. LinkedIn, Indeed, Dice are really good tried and true places, but also network on unconventional platforms like Facebook and other platforms like social medias. So just to wrap it back around, our summary here for our roadmap is step one, pick a specialization. Step two, learn hardware fundamentals. Step three, gain specialized skills based on that specialization that you chose. Step four, get hands-on experience with real world projects. And step five, earn that certification and apply for jobs.